Hi guys, I'm gonna do the 7-4 homework here. So this was page 393 and it is 3 to 55 every other odd. So page 393, 3 to 55 every other odd. Now, if you have trouble with any section of problems, so like the questions from 3 to 8 is a section, the questions from 9 to 12, I can show you here. Like if you are looking at this and you struggle with a question out of this section, I want you to do all the odds in that section. Okay, that's the deal. So, okay, let's start with number 3. So number 3 says, for any rhombus, so I would like to be looking at a rhombus, JKLM, for any rhombus, describe whether the statement is always, sometimes, is it always, sometimes, never? No, just always or sometimes. Okay. All right, so the first one is that angle L is congruent to angle M, these two. What is the deal there? Is angle L congruent to angle M? Well, a rhombus is always a parallelogram. But only sometimes a square. Okay? If you remember the chart, the family tree, the rhombus has all the properties of the parallelogram, but only sometimes is it a square. So L and M being side by side, we are only guaranteed, because a rhombus is a parallelogram, for these to be supplementary. We are not guaranteed for them to be congruent, unless it's a square, which it only sometimes is. So this is a sometimes. Okay, so now we'll skip 5 and go to 7, because it's every other odd. And it wants to know, what about JL congruent to KM? So JL is a diagonal here, and then KM here. So now again, a rhombus is a parallelogram always, but a square sometimes, okay? In a square, diagonals are congruent, but in a parallelogram, no, not in a parallelogram. And I can even tell that this one is shorter than that one. So this is again a sometimes. Okay, now number 9 I'll skip and go to 11. 11, classify the quadrilateral and explain your reasoning. So they've got like a door or something, and then this is the diagram that they've got drawn, and I have these markings and these right here, and that's all that they have told me. So let's see. If these two sides are congruent, and then these here being supplementary, because this is 90 and this is 90, makes these lines parallel. So I know that I've got at least a parallelogram. And then if I know I have a parallelogram, then opposite angles are congruent. And now my parallelogram has 4 90-degree angles. It has turned into a rectangle. I know it looked like a rectangle, but we had to mathematically be right about it. So, rectangle. Now, I'll skip 13 and go to 15. But if you struggle with 15, I urge you to also do 13. Find the measure of the numbered angles in the rhombus. So we know this guy's a rhombus. And then we have all these numbers. 1, 2, 3, 4, and 5. And then they give me only one angle and they tell me that this one is 106. Well, a rhombus is a parallelogram, so now I know that the measure of angle 5 is 106 because across from each other. And then because a rhombus is a parallelogram, if this angle is 106, then this angle, complete angle all the way across, would be 180 minus 106, which makes it 64. Is that right? No, it makes it 74. What am I saying? Sorry, guys. 74 degrees. So this full angle is 74 degrees. But now, if this is a rhombus, this diagonal actually does bisect this angle, which then means that the full angle being 74, each one of these is half of 74. So, and opposite angles are congruent, so all of these guys are congruent. So the measure of angle 1 is equal to the measure of angle 2, and it's equal to the measure of angle 3, and it's equal to the measure of angle 4, and all of these are equal to 37 degrees. So now 15, skip 17, go to 19. 19 says for any rectangle. I feel like we're all a little bit more comfortable with rectangles for some reason. So here's a rectangle, and it's rectangle WXYZ. And are we always or sometimes? So for 19, it says that WX is congruent to XY. Okay, sometimes if this rectangle were a square, it would be true, but always, absolutely not. Okay, skip 21, we're at 23. Ooh, determine whether the quadrilateral is a rectangle. So we don't even know if it's a parallelogram. They called it a quadrilateral. That's like no information whatsoever practically. But we have this. So what this is opposite angles congruent. And if you remember that opposite angles theorem that we went over, that only definitively tells us that we have a parallelogram. And that's as specific as it gets. We don't know enough to call this a rectangle. Can't call it a rectangle. Okay? Now, if all four of these were marked as congruent, all four, then there'd be only one option for them to be 90, which means then it would have been, but not this time. Okay, so 23, skip 25, go to 27. Find the lengths of the diagonals of the rectangle. So here's our rectangle. The 90-degree angles of a rectangle make it so that the diagonals are congruent to each other. WXYZ. So here's a rectangle. WY is a diagonal. XZ is a diagonal. WY equals 6x minus 7. XZ equals 3x plus 2. This is a rectangle, meaning diagonals are congruent to each other. So we set these equal to each other. Subtract the 3x from both sides. Add the 7 to both sides. So x is equal to 3. And then they didn't want x. They wanted the lengths of the diagonal, so I have to plug 3 back in here. 6 times 3 is 18, minus 7 is 11. And because I know these are congruent, I don't have to plug it into the second one, but if I do, I'll be double checking my answer. So 3 times 3 is 9, and then plus 2 is 11. So WY is equal to, oh my gosh, XC, which is equal to 11. Okay. All right. 27. So we'll skip 29 and take a look at 31. Name each quadrilateral, a parallelogram, rectangle, rhombus, or square, for which the statement is always true. So for 31, we are told that it is equiangular and equilateral. So it has 4 sides because they did call it a quadrilateral. If it has 4 sides and it's equiangular, a quadrilateral has 360 total degrees. And if it's equiangular, we need to split that up between 4 angles. So we definitely do get right angles. And then if it's equilateral, each of the sides has to be the same length. So same length, boom, 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 and boom, a boom, boom, and boom. That is a square. Absolutely, it is a square. Square is the hardest thing to be. So that's the one that was least likely to come out as always true, but that is what we had that time. Okay, 35. Error analysis. Quadrilateral PQRS. Let's look at this one so you can see the whole thing. Quadrilateral PQRS is a rectangle. Describe and correct the error in finding the value of x. So this guy's a rectangle. It has its diagonal drawn, okay? And I mean, this person is saying that QSR, so from Q to S to R, that angle x, they're saying that's equal to QSP 58. And they're saying x is 58. Well, that would only be true if this diagonal bisected that angle. Diagonals bisecting the angles, that happens in a rhombus, not a rectangle. Okay, so that happens when all sides are congruent, not in a rectangle. That is their error. They mistook this guy for a rhombus. X does not equal 58. We actually don't have enough information to find x. Okay? Alrighty. 30, that was 35. It is a rectangle, not rhombus. Therefore, diagonals do not necessarily bisect the angles. Okay, 39. Are we getting good at skipping every other odd yet? It's always tricky for me. The diagonals of a rhombus intersect at E given, okay, so they've given us a rhombus. Not the best rhombus ever, but it works. And then they are telling me that this is 53. They're also telling me that this is 6 and this is 8. And then they want me to find stuff, okay? So for 39, they want me to find the measure of angle DAC. DAC, right there. DAC. So DAC, I mean, in a rhombus, the diagonals do bisect the angles. So if this guy is 53, this guy is 53. Done. Okay. So we'll skip 41 and go to 43. Now we've got a rectangle. So you guys, if you are struggling with this problem, if you came to the video to specifically check 39, then I really hope you're also doing 37 and 41, okay? The answers are in the back of the book, so you can check to see if you're right. And you can ask me definitely when I ask you for homework questions in class. So, Q, R, S, T. The diagonals of a rectangle intersected P, okay. So in a rectangle, we know the diagonals are congruent to each other. That's basically it. PTS. PTS, this angle, is 34 degrees. And QS, that full guy right here, this whole thing, that full side is 10. Find the indicated measure. So for 43, QTR, measure of angle QTR. QTR, this one they want. Okay, so it's a rectangle, which means I know that the angle is not necessarily bisected. But what I do know is that the full angle is 90 degrees. So if the whole thing's 90, that portion is 34, this guy is going to be 90 minus 34. So it is 56. Okay. And 45 will be skipped, but we'll go to 47, which is in this section. They also want to know about RT. RT. How long is this entire diagonal? Well, in a rectangle, diagonals are congruent. So if this diagonal is 10, then this diagonal is also 10. Okay? So the hardest part of these is just remembering that theorem. Okay? It's not the problem that's hard. It's remembering all the different random little properties. 51. Oh my gosh, we're already on 51. The diagonals of a square. It's so easy to draw a square on graph paper. LMNP. Intersected K. One. Find the indicated measure. Okay, so measure of angle LPK. Notice they told me nothing about the angles. That's because telling us this is a square already tells us so much about the angles. It tells us all of these angles are 90. It tells us that these diagonals bisect these angles, so it tells us all these little mini angles are 45 because they're half of 90 each one. So when it comes to squares, they really don't have to give us a whole lot of information about the angles because just it being a square on its own is a whole lot of information. So L to P to K, which is in the middle, LPK is one of the mini angles. It's 45 degrees. Okay. And then 51. So we'll skip 53 and we'll do 55. Decide whether parallelogram, look at this, they gave us this symbol. So they are guaranteeing that we've got a parallelogram. JKLM is a rectangle, a rhombus, or a square, and justify. So I'm going to draw us a graph. the more accurate of a graph, the easier it'll be for your eyes to see it and decide what plan of action we should use. So J is negative 4, 2. Negative 1, 2, 3, 4, up 2. K is 0, 1, 2, 3. L is 1, negative 1. And M is negative 1, 2, 3, negative 1, 2. Negative 3, negative 2. So here we have these guys. This accurate drawing allows me to have a hypothesis about this already. My hypothesis is that these are 90-degree angles. I'm not sure yet. And that all of these are congruent. So I'm thinking I'm proving this guy to be a square. So now, for it to be a square, there's a couple ways to go about it, but probably the simplest way, I want to first show that these guys are perpendicular. All these angles are perpendicular. So in order to prove that they're perpendicular, I'm going to find their slopes. Okay, slopes are subtract the y's and subtract the x's. So this is what I'll do. I'm going to subtract the y between j and m. So 2 minus negative 2. 2 minus negative 2 becomes 2 plus 2, which is 4. And then negative 4 minus negative 3, negative 4 plus 3 is negative 1. Then I'm going to find the slope here. So 3 minus 2 is 1. And 0 minus negative 4 is 0 plus 4, which is 4. So slopes are in red. I'm going to do it here. 3 minus negative 1 is 3 plus 1, which is 4. Actually, they told me this is a parallelogram. So technically, I don't need to find these slopes because given that it's a parallelogram, opposite sides are parallel, which means I'll automatically know that this is going to have the same slope. But if you did the subtract 0 minus 1, you'd get negative 1. And then I know this has to be the same slope as this. Okay, and now looking, this is a 1 over 4, and this is a negative 4 over 1. These two slopes are opposite reciprocals. Which means, therefore, the lines are perpendicular, which means that I have just shown that I, at the least, have a rectangle. Okay? And then I know that opposite sides are congruent because they told me that this is a parallelogram. So if I can just show that this side is congruent to this side, then I've also shown that it's a square. So you guys, I don't know if you can use Pythagorean theorem. That would be kind of easier, but I guess we got to use the distance formula. And I didn't leave myself enough space for that, unfortunately. So let's do distance formula here between j and k. And I'm not going to get to write the distance formula for you, but I hope you remember it. I can write it. I can fit it right here. Distance formula, square root of x2 minus x1 squared plus y2 minus y1 squared. And I do have the x2 minus x1 squared and the y2 minus y1 squared because I did them when I did the slope formula. So to shorten this, but again, feel free to just take the points and subtract them. Subtracting my x's would be on the bottom of the slope formula. So for jk, it's 4. squared minus, and then subtracting the y's would be on top of my slope formula, which is 1 squared. And then that equals square root of 16 minus 1, which is the square root of 15. And then to find the distance between J and M, it's the square root of, okay, x2 minus x1 is this -1 squared, plus y2 minus y1 is the 4 squared, which is the square root of 1 plus 16. Oh no, it's not a plus in the middle, it's a minus. I wrote plus on by mistake. And that is 16. Wait, no, it is a plus in the middle. What am I saying? Did I write my... No, it was a plus this whole time and I've been doing it wrong. I'm so sorry. 16 plus 1 is 17. So this is square root of 17. And then here, this is 1 plus 16, which is 17, square root of 17. And so now I just showed that the sides are all congruent too. This one is congruent to this one. And then because it's a parallelogram, opposite sides are congruent. So my hypothesis was right. Parallelogram JKLM is really a square. All right, that was a good problem. I really like that problem. I would probably make sure I knew how to do that problem. Okay,